Hey folks, Jim here with Science Talk. I want to discuss with you this article that appeared in the online publication EOS. And as you can see here from the headlines, tracking climate through ship exhaust. International regulations have reduced aerosol pollutants released from ships. Now, researchers want to use ship tracks to better understand the ambiguous effects that cleaner air has on climate. Okay. Now, this is interesting that I just recently posted a video looking at the effects of aerosols from ship exhaust and what that does to climate. And I featured research that was submitted at a conference by uh, Leon Simon and Dr. James Hansen. So you may want to check out that video. And of course, the whole thing with aerosol is that we have as Guy McPherson is always pushing, or as he's always making the case that the aerosol masking effect is actually without that, we would even be warmer. So now, if you reduce the aerosols, do we make the planet warmer? It's basically damned if you do, damned if you don't. We don't have any problems with the cursor here. So anyway, um, so scientists have taken a closer look at emissions associated with ship tracks. That's what these are. These are all emissions from ship smokestacks. And it says, like these crossing the Pacific Ocean south of Alaska. Ship traffic up in the North Pacific. A total of 99,800 commercial ships, almost 100,000, sail the seas, carrying around 90% of the world's trade in goods. Their operation is vital. For example, COVID-19 vaccines were transported using vessels. The fuel oil that runs these immense vessels can contain up to 33,500 times more sulfur than the diesel that is used for land vehicles. When the fuel is burned, large amounts of sulfur oxides and other aerosols are released into the atmosphere. These aerosols increase the concentration of droplets in marine low clouds, which make them appear brighter. These bright clouds trail ships and can be seen in satellite images. Basically, what they're saying here is that the aerosols provide what's called hygroscopic particles that allows water molecules to coalesce around it. Most people are unaware that in order to form like rain droplets, you need to have some little speck of a particle at the center of it, this hygroscopic particle that allows the water molecules, more precisely the dihydrogen oxide molecules, to coalesce around that uh, particle. It's just like, in order to for the oyster to start forming the pearl, it needs an irritation. That's usually a grain of sand. So it's that kind of an idea. And I say these bright clouds and other trail shit can be seen in images, such as here. Okay, and let's see if we can play the little GIF here for you. Now you can see the coast of California there, and you can see. Play one more time. Was the satellite image swinging around, but you can see. These are all from vessels. All of these are from vessels. Okay, 2018, Tianle Yuan, a University of Maryland, Baltimore County atmospheric scientist at NASA's Goddard Space Flight Center, and his team began developing a machine learning algorithm that automatically identifies these ship tracks. After years of tweaking the algorithm using satellite imagery, They created the first global map of ship tracks with data spanning the past 18 years. Before our study, the largest sample contained about 5,000 ship tracks, and that's already a huge effort, but now we have hundreds of thousands, maybe millions. The team's first finding after analyzing the monitoring map is good news for both people and ocean health. Okay. First, they say, okay, so the subheadline regulations are working. Sulfur oxides are harmful to people's respiratory health and damaging the ocean ecosystems. When the particles reach the atmosphere, they quickly become surrounded by water, right? That's, the dihydrogen oxide coalescing, promote cloud creation. These clouds produce acid rain because you have sulfur oxide plus water is going to give you sulfurous or perhaps sulfuric acid. And of course, if that falls to the ocean, which invariably it will do, it's going to decrease the pH. And if it doesn't fall in the ocean, if it moves over land, well, then it's going to affect the crops and the forests near the coast. And there's the ocean acidification I just alluded to. And of course, that impacts not just marine ecosystems, but any terrestrial ecosystems subjected, exposed to this acid rain. As a response to shipping related air pollution, the United Nations International Maritime Organization, IMO, that does not mean in my opinion, started implementing limits on the sulfur content in fuels. In 2015, a sulfur content limit of 0.1% was established for ships sailing within emission control areas, known as ECAs. Outside these ECAs, the sulfur content limit was reduced from 3.5% to 0.5%. That's a huge decrease in 2020. Together, the latest regulations account for an annual reduction of 8.5 million metric tons of sulfur oxides, which is basically 77% of total emissions, according to the IMO, right? The International Maritime Organization agency data. The results obtained by Juan and his team, published in Science Advances, put those numbers into perspective. Within the ECAs, most of the ship tracks just disappeared. Regulations are working, he says. Although the COVID 19 pandemic affected maritime trade, the number of ship tracks in the ECAs continued to decline, even as trade began to recover between late 2020 and early 2021. However, analyzing data from the U.S. West Coast, the scientists noted that since the implementation of the ECA limits in 2015, several ships changed their routes to the south outside the ECA, basically to avoid detection. While shipping traffic from LA, Los Angeles, and San Diego ports decreased, hotspots were found in Baja California, just behind the ECA. Hmm. Although there is no hard evidence, Captain Ricardo Valdez of Mexico's Secretariat of the Navy would also not doubt that ships may be evading ECAs to avoid buying cleaner fuels. Oh, anything that cuts into the profit, we're going to not want to do. And those cleaner fuels, as you can expect, cost more. Valdez has been sailing for 35 years and is very familiar with shipping policies and practices. In fact, in 2018, Mexico's Ministry of Environment and Natural Resources, CEMARNAT, sought to create its own ECA because the lack of regulation on emissions was causing vessels to use cheap, polluting fuel when arriving in Mexican national waters. We want to control the emissions from the ships that transit our waters, 75% of which are foreign, so that these emissions are as few as possible, said Rodolfo Lacey of Semarnat. Ultimately, the IMO declined Mexico's initiative because the country is not a signatory to Annex 6 of the International Convention for the Prevention of Pollution from Ships, the mechanism through which emission limits are implemented. Oh, sounds like Mexico needs to address that. Although the IMO already has an emissions inventory based on automatic identification system data that lets it identify ship emissions, fuel consumption, and energy use, Juan's team algorithm is useful for validating some of the bottom modeling that's used as the basis for IMO decision making, said environmental scientist Brian Comer, who leads the International Council on Clean Transportation's Marine Program. The algorithm could also be an excellent tool for monitoring evading ships and their emissions, Valdez says, but it will be useful only if Mexico works to adhere to IMO agreements. Mexico can't require a foreign ship to comply with some standards if its own ships don't. The tools and legislation exist, but, and how often have we heard this? Political will is needed. That's a very familiar song, isn't it? The road to decarbonization. In addition to emitting sulfur aerosols, bright ship tracks reflect the sun's rays, a process that generates a cooling effect in the atmosphere. Kind of what I alluded to at the early portions of this video of how the AME, aerosol masking effect, has actually reduced how much warming all the burning of fossil fuels that humans have done, reduce how much warming it would actually be. However, measuring this effect is extremely difficult because environmental conditions in each region affects clouds in different ways. Clouds are difficult to put into modeling because the top of clouds reflects sunlight, so there's an albedo aspect, but the bottom of clouds traps heat. So is a cloud a contributor to warming things up, or does it help keep things cool? Well, how thick's the cloud? At what altitude is it? Is a lot of factors that go into it. And, the water moisture, the water vapor content from clouds is an extremely difficult parameter to get a handle on when constructing climate models. As the old joke goes, when you look at Star Trek, the original series, Enterprise approaches a planet, getting ready to assume standard orbit, and they show the planet, and if you can see the surface very nicely, there's not a cloud in the sky because clouds are difficult to model. Yes, kind of a geeky joke, but yeah, there it is. So the IPCC has stated that aerosol cloud interactions constitute the biggest uncertainty in climate projections. And if you're over if you have all these ships, sailing all over the ocean, especially the Pacific, yeah, it's difficult to get that data. So it's difficult to quantify. It's difficult to get an idea of how much is there quantity-wise, the rate at which it is being released. Very difficult to get that data, that information. So yes, that is a statement I cannot really quibble with. Recent studies have shown that although global air pollution has decreased by up to 30% from 2000 levels, cleaner air may have increased warming by 15 to 50% because of the removal of the AME. Still, the IPCC report points out that strong, rapid, and sustained reductions in methane, another greenhouse gas emission, would also limit the warming effect resulting from declining aerosol pollution and would improve air quality. Okay, I see what this is trying to say there. If we're burning less fossil fuels, okay, you're going to be, there's less greenhouse gases going into the atmosphere. So presumably that would help uh, decrease or lower any warming effect. But this is not being mentioned here, and I'm going to say it. 93% of the energy from our burning of fossil fuels ends up in the oceans. And that heat is going to diffuse at some point back to the atmosphere. Folks, we're screwed no matter what. Be quite blunt about it. The IMO is aware of this. Comer explained that decarbonizing the maritime sector would produce benefits to both health and climate. The main issue, he said, is that decarbonization will reduce the atmospheric concentration of greenhouse gases. We should not take any steps backwards. Okay, you know, I'm not going to say you shouldn't reduce the concentration of greenhouse gases. I'm just kind of putting a bit of a blunt reminder out there that you have the ocean heat content that's just at some point will diffuse back to the atmosphere, especially with sequestration to depth slowing down so that there is a stratification taking place, and most of this heat is found in the upper 500, 700 meters or so. Yeah, that's going to diffuse, and that will actually increase the warming. And, either way, the warming is going to continue. For Columbia University climate scientist James Hansen, Juan's work is an important element that will help scientists better understand the complex role of aerosols in climate change. The constant change of clouds makes it extremely difficult to study how they interact with aerosols. But ship tracks are perfect laboratories to study these interactions. There is very little change in and out of the plume of exhaust emitted by ships as they sail under the clouds, so scientists can attribute changes in the clouds more directly, though never entirely, to the aerosols. The radiation balance of the planet seems to be affected as we expected, but the record needs to be longer to quantify the impact. Humanity is in the process of doing a large scale experiment with the planet that potentially can provide important information about future climate. This is a case where use of satellites is very important. Really, the only way you can hope to get this information, this data. So basically, if you really want to get as complete of this information as needed, you need a hell of a lot more satellites. You need considerably more extensive flyovers, and just a lot more data that's needed. So this is interesting, and wanted to bring this with you. As I mentioned earlier, you may want to check out the recent video I did about aerosol reduction, featuring the work of Leon Simon and Dr. Hansen. Um, they talked about looking at plumes from ocean vessels. So I see these two videos being linked together, and so anyway, there you have it. Until next time.